Hello, dear students. Welcome back to Hybrid Learning. This is part 2 of the CBSE Grade 10 Pre-Board Revision. Let's get started. So today we will continue with the Section C questions, which are 1 mark each, part questions. Okay. An electric iron has a rating of 750 watt to 20 volt. Calculate the current flowing through it. We have done a numerous problem related to power. Okay, so if you have doubts in these questions, you can go through the videos in the playlist and you can pause the video and try this question by yourself. So how do we do the first question? The formula for the power, because it is given the rated electric iron rating, means it is the power and potential, PV rating. So given is power, that is 750 watt, and your potential is 220 volt. So we know P is equal to VI, very important formula. You will get a lot of questions based on this formula, and you have to solve also a lot of questions based on this formula. Okay, so you have to find current. So I is equal to P by V. Now we can substitute 750 divided by 220. So you can do the cancellation. 75 by 22. So if you do the cancellation, you will get the answer approximately 3.4 ampere. Or you can take 3.409 like that. Minimum, you can take 2 places of decimal. That will be better. Next, number 2. Resistance of a metal wire of length 5 meter is 100 ohm. If the area of cross section of the wire is 3 into 10 to the power minus 7 meters square, calculate the resistivity of the material. Pause the question, try the question yourself, and then check out for the answer. So given is length 5 meters, resistance is given as 100 ohm, and resistivity we have to find out, area is given as 3 into 10 to the power minus 7 meters square. So we know R is equal to rho L by A. What is this rho? The rho is the resistivity. Okay. So we have to calculate the resistivity of the material. So rho will be, let's write it, rearrange the other terms. RA by L, we can substitute 100 into area divided by length is 5. So that's 60 into 10 to the power minus 7, or you can also write 6 into 10 to the power minus 6. It's up to you. Now the SI unit for resistivity is ohm meters. Okay. If you have a problem in remembering the SI unit, you can use the formula and you can derive it. Okay. You can use the formula and you can do the derivation. We have also discussed this previously. You can go through the playlist. Let's go to the next problem. This is from magnetic effect of electric current. Very important question. State the Fleming's left-hand rule. Fleming's left-hand rule is used to find out the force acting on a current-carrying conductor. Okay. Now, how do we define Fleming's left-hand rule? So you have to take the first 3 fingers of your left hand in mutually perpendicular direction, where your first finger represents the magnetic field, second finger represents the current, and the thumb will point in the direction of the motion or the force. So this is what you have to write. Clearly, the statement has to be mentioned. All the fingers, which finger denotes what, has to be mentioned, and where you are getting the force or motion, that has to be mentioned. So you will get the marks. Let's go to number 2. When is the force experienced by a current carrying conductor placed in a uniform magnetic field maximum or minimum? Okay. Now, as I already said, you have to keep the left hand of your finger in mutually perpendicular direction. So force is maximum when it is perpendicular, when the conductor is perpendicular to the field. Okay. So your A part is when the conductor is perpendicular to the field. So that means when your angle between them is 90 degree, then you will get it as maximum. B, same thing when the conductor is parallel to the field. That is, when the angle between them is 0 degree, then it is minimum. So this is the condition for maximum force. This is the condition for the minimum force. Okay, I hope you understand. We'll come up with many more parts of this science playlist. Okay, please, if you like the video, please give a like, subscribe to the channel and follow us for more. Thank you. Bye bye. See you in the next video.